Some of the structures you are about to see are nearly 2,000 years old. They were built without steel, without modern surveying equipment, without computers, and without any formal understanding of structural engineering as we define it today. And yet many of them are still standing, still intact, and in some cases, still being used. This list is not ranked by fame or popularity. It is ranked by engineering difficulty, precision required, and how close each structure came to structural failure. By the end, you will see one building that, even by modern standards, should not still exist. Ready? Let's roam. Number 10. Roman Forum. The Roman Forum was not a single engineering project. It was a continuously evolving system shaped over centuries. This area was originally a marshy valley prone to flooding. And before monumental buildings could rise here, Roman engineers had to drain the land, redirect water, stabilize the soil, and create foundations capable of supporting heavy stone structures. Over time, temples, basilicas, roads, and administrative buildings were added, removed, and rebuilt, often directly on top of earlier construction. What makes the Forum impressive is not one building, but coordination. Drainage systems had to coexist with roads, foundations had to support structures that were never part of the original plan, and new construction had to account for what already existed underground. This is Roman engineering at the city scale, not a single moment of brilliance, but centuries of problem-solving layered into one space. Number 9. Via Appia. The Via Appia was built beginning in 312 BC, and sections of it are still walkable today. Roman roads were not simple dirt paths. They were engineered layers of stone designed for drainage, durability, and constant heavy use. A typical Roman road included a prepared foundation, compacted gravel layers, and tightly fitted paving stones that resisted shifting over time. These roads allowed Roman armies to move faster than their enemies, supplies to travel efficiently across long distances, and messages to reach distant provinces reliably. The engineering itself was repetitive, but the strategy behind it was transformative. Rome did not conquer the Mediterranean world through brute force alone. It conquered by making movement predictable, fast, and dependable. Infrastructure was power. Number 8. Baths of Caracalla. The Baths of Caracalla were among the largest public buildings in the ancient world and functioned as a massive social and recreational complex designed to serve thousands of people every day. Inside were hot baths, cold baths, warm rooms, exercise areas, and open courtyards, all supported by an extensive hypocaust system where hot air circulated beneath the floors to heat the rooms above. This required precise coordination between water supply, heating, ventilation, and structural support. Large volumes of water had to arrive continuously, wastewater had to be removed efficiently, and floors had to support enormous weight while allowing heat to circulate below. This was mechanical engineering at an urban scale, executed entirely with masonry, brick, and concrete. Number 7. Aqueduct of Segovia. The Aqueduct of Segovia rises above the city on a long series of stone arches, and at first glance it looks deceptively simple. Much of the structure was built without mortar, relying instead on perfectly cut stone, gravity, and compression to remain stable. The real challenge, however, was the water itself. The channel at the top had to maintain a consistent slope over long distances. Too steep, and the water would erode the channel. Too shallow, and it would stop flowing entirely. This is one of the first structures on the list where small errors could cause complete failure, and the fact that it still stands today is evidence of extraordinary precision. Number 6. Pont du Gard. The Pont du Gard takes everything seen at Segovia and raises the difficulty significantly. This 3-level aqueduct bridge spans a river valley, with massive lower arches supporting the structure, while the uppermost level carries the water channel itself. The entire bridge exists to preserve the precise elevation required for water to flow correctly over long distances. The Romans did not build this bridge for decoration, they built it because the terrain demanded it. The true engineering achievement here is invisible. The consistent slope of the water channel maintained across miles of uneven landscape. The bridge is impressive, but the mathematics behind it are extraordinary. Number 5. Colosseum. The Colosseum was engineered for scale, speed, and control. More than 50,000 spectators could enter, find their seats, and exit efficiently through a carefully designed system of corridors and stairways. The structure relies on stacked arches and vaults that distribute weight outward and downward, allowing the building to reach immense size without relying on solid walls. Beneath the arena floor, mechanical systems supported staging, scenery, and animal lifts. This was not simply architecture, it was crowd management, logistics, and structural engineering combined into a single operational machine. Number 4. El Jem Amphitheatre. The amphitheatre of El Jem applies the engineering of the Colosseum at nearly the same scale, but far from Rome itself. Constructing a structure of this size required transporting materials, coordinating skilled labor, and maintaining Roman construction standards across vast distances. The amphitheatre had to be adapted to local conditions while still functioning exactly as intended. This was not a one-time achievement. It was proof that Roman engineering systems were repeatable and transferable across the empire. Rome was not just building monuments, it was exporting expertise. Number 3. Hadrian's Wall. Hadrian's Wall stretched across northern Britain for more than 70 miles and functioned as far more than a defensive barrier. It was an integrated border system that included forts, mile castles, roads, and supply routes, controlling movement, trade, and taxation as much as security. Soldiers lived along it, goods moved through it, and information flowed across it. Engineering at this scale is less about precision and more about coordination, ensuring that every component functions as part of a larger whole. Rome was not just building structures here, it was engineering territory itself. Number 2. Castel Sant'Angelo. Originally built as Emperor Hadrian's mausoleum, Castel Sant'Angelo is a massive cylindrical core of Roman concrete designed to support enormous weight and resist decay. Over centuries, it was transformed into a fortress, a military stronghold, and a papal refuge, with each adaptation relying on the strength of the original Roman construction. Its thick walls absorbed time, earthquakes, and warfare, representing a different engineering philosophy from precision-based structures. When accuracy was not possible, the Romans built with redundancy, massive cores, heavy walls, and materials designed to absorb stress and endure. Number 1. The Pantheon. The Pantheon is the largest unreinforced concrete dome ever built, and it remains structurally unmatched. There is no steel framework and no internal support system. Every part of the dome is held together by compression alone, meaning a single major crack in the wrong place could cause catastrophic collapse. The Romans solved this by changing the concrete mixture as the dome rises, making it lighter toward the top, carving deep coffers to remove unnecessary mass, and leaving the oculus open to relieve stress at the most dangerous point. Every square meter of this dome is pushing inward, and nearly 2,000 years later, it still stands. Roman engineering was not about decoration. It was about systems, materials, and understanding failure. When you walk through these places today, you are not just seeing ruins. You are standing inside solutions to problems humanity had never solved before. And in at least one case, we still are not sure how they pulled it off. If you enjoyed this breakdown of Roman engineering, make sure to like this video, subscribe to the channel, and let me know in the comments which structure surprised you the most, or which one you think should have made the list. Your support helps this channel grow, and it lets me keep making deep dives like this. Until next time, keep roaming.